Okay, let's solve for this. First equation was easy, just a linear inequality. So we have 1 greater than 5x, 1 over 5 greater than x. So we better write x smaller than 1 over 5. Okay, we better write x smaller than 1 over 5. And to write the set notation, so what's the domain? Domain, you need to talk about x. So x belongs to what? This x can be an element of negative infinity and to 1 over 5 with round bracket because you cannot reach 1 over 5. Okay, so x needs to be smaller than 1 over 5, which means x belongs to one of the value in the set of negative infinity to 1 on 5. Okay, that's a notation how we talk about domain. So x belongs to a set. Okay, x belongs to a set. Okay, for the next one, we have two inequalities and we want to find a common part. Okay, I want a set of x can satisfy the first inequality and also satisfy the second inequality. So we solve out the solution for two inequalities and we find the intersection part. That part should be the value satisfy both equations. So what I will have is 2x greater than 5, x greater than 5 over 2. For this one, I have 10 greater than 3x, and x is smaller than 10 over 3. Okay, x is smaller than 10. Sorry, we should have equal sign here because it's just a normal inequality, so we should have equal sign here. Okay, they can be greater or equals to 0. It's not on the denominator, so I will have that thing can be equivalent to 0. Okay, can include 0. So how we can find intersections between two sets? Okay, so that's an easy one. So you may can see it directly. But like say if we have 3 inequalities or 4 inequalities, what's the method we use to find the intersections between those inequalities? So we will sketch number line. Okay, we'll sketch number lines. Okay, how we can sketch that? Let's do number line here and find those two values, 5 over 2 and 10 over 3. 5 over 2 is 2.5. 10 over 3 is 3.3333. Okay, so 5 over 2 should be here and 10 over 3 should be here. Just list the order, like from the smallest to largest. So I'll use red to represent x greater or equals to 5 over 2. So it's a closed circle because x can take 5 over 2. So it's all the set values here. Okay, I'll use the green color to draw the second one. Second one is x smaller or equals to 10 over 3. So it will be start from here and all the way to here. So what is the intersection? So the intersection is the area where contain two color lines. Two color lines. So if I draw dot lines here, that's the stop point. Okay, those two, between those two values, I have two color lines. So my x should be in between 5 over 2 to 10 over 3 inclusive. Okay, 5 over 2 to 10 over 3 inclusive. Okay, because we can take those 2 points. Okay, we can take those 2 points. Okay, that one is showing you how to find intersections. And let's have a look at the next one. The next one, like, is under the denominator, so the thing needs to be greater than 0, not equivalent to 0. But this is a quadratic inequality, right? Quadratic inequality. How we can solve quadratic inequalities? We need the graph, okay, to help us to solve for that. I'll teach that in chapter 3. So we have x plus 1 and x plus 6 to factorize that. Okay, x plus 1 and x plus 6 to factorize that. We have 7x in the middle and the constant of 6. Okay, now we want to sketch for this. And I don't need to sketch y-axis. We just need to label the x-intercept, which is -1 and -6. So this is a happy face graph. So it's upward, have those two x-intercept. Okay? And we need what? I need this value greater than 0. So where is greater than 0? Greater than 0 will be this part and this part, the above x-axis, but not including this endpoint here. It's an open circle here because I cannot make that equals to 0. So those two part is open circle. So where I need, that's the x which can give me y greater than 0. That's the x can give me y greater than 0. So my x should be smaller than -1, or my x should be greater than wait, I draw it wrong way. So here is -6, here is -1. Okay, -6 should be on the left hand side. So -6 here and -1 here. So x should be smaller than -6 and x should be greater than -1. Okay, -6 on the left, -1 on the right, and that shape smaller than -6, greater than -1. And we'll write, okay, we have two ways to write this, okay, it's important, two ways to write that. It's actually two sets, okay, two sets. We have smaller than -6 and greater than -1. So we can write x belongs to -infinity to -6, not including -6, union -1 to infinity, not including -1. So two set union together is the, okay, union set of that. Yep. Yeah, I'm going to teach the next one later. Okay, so we can use, that's the first method, like you really follow the logic. I want this and I want this. And the next one will be like a little bit shorter way, but like you need to think about this a little bit. So it can belong to anything except, okay, except what? Except the middle area from -6 to -1, right? Can be anything else except those middle parts. Okay, the middle part is -6 to -1. So, okay, -6 to -1. But think about, should we use round bracket or square bracket here? Square? Okay, square. So it should be square because I need to exclude that out. So after the slash line, the sign, it means I don't want what? Okay, I don't want what? So what I don't want -6, I don't want -1 because those two values can make the equation be 0. So I don't want 0. I should have a square bracket, means, okay, -6 and -1 in between those values, including those two values, needs to be excluding out. Okay, so it should be square bracket after that excluding sign. Let's use the set difference. Okay, remember that means set difference. Set difference means the elements in A but not in B. Okay, so R is in A, like everything in set A, but excluding the things in set B. So that should be equivalent. Okay, both methods should be the same. Okay, next one. Next one is 4x plus 1 greater than 0 and 2x minus 1 not to be 0. So I have 4x greater or equals to -1 and x needs to be greater or equals to -1/4. Okay, and at the same time my 2x cannot be 1. X cannot be a half. Okay, write it up. 2x can't equals to 1, x cannot equals to a half. Okay, so let's think about what this looks like. Okay, x greater, that's two set, right? I have -1/4 and we have a half here. So greater or equals to -1/4 will be everything here, but not including a half. The half is included in this set. So I will have an open circle here. Okay, I don't have that value. Okay, I don't have that value. Okay, that's how this graph looks like. So still two ways we can write that. X can belongs to, okay, start from -1/4 until this point a half, but round bracket because I don't want to take a half. Union, start from a half but not including a half to infinity. So that's one way to write that. Okay, the second way to write this will be a set from negative a quarter to infinity. Excluding what? I'm excluding a point. Okay, not excluding a set of values. It's excluding a point. So I need to write that point in the set notation. Okay, I need to write the point in the set notation. I cannot write a half like this. So I will write a curly bracket. The curly bracket can make number become set. Okay, add a curly bracket around the number, and that means it's a set. And only have one element in the set, which is a half. So from negative a quarter to infinity, I want to excluding a half out. That's the way of writing it. Okay, any questions about this? Okay, that's 4 different types. If you can see, that's solving for 4 different types. Okay, solving for linear inequalities, quadratic inequalities, solving for intersections between 2 linear inequalities, solving 1 linear inequalities, and solving 1 linear inequality plus a point not equivalent, okay, not equals to a point. So that's how we find implied domain, okay, maximal domain. Okay, let's go to the next page. Let's go to the next page. 5F. Applying function notation. Okay, applying function notation. Example 1. R to R. Example 1. If f is r to r, fx equals to x plus b, such that f1 equals to 7 and f5 equals to 19, find value of a and b. So this is like nothing hard. It's really like similar to before, like give you y equals to x plus b, and give you x equals to 1, y equals to 7, x equals to 5, y equals to 19, and ask you to find the parameters of a and b. Okay, so it's all the same. You just change that to function notation to deal with. So let's do f1. So what is f1? f1 means sub 1 into the equation, means it's a plus b. And also give you f1 equals to 7. So you have a plus b equals to 7. So what is f5? f5 is 5a plus b, because instead of x, you will write 5. So it's 5a plus b, and that gives you 19. Okay, let's say that's number 1, that's number 2. I can use number 2 to subtract number 1. I have 4a equals to 12. A will be 3. Okay, sub a equals to 3 into equation 1. Then b will equals to 7 minus 3. B equals to 4. So a equals to 3. B equals to 4. Okay, so we just use function notation to solve like similar questions. Okay, it's the question like year 9, year 10. So we use the same way to solve for that. Still solve linear simultaneous equations, but we only just use fx. Okay, we use fx. Okay, for the next one. Example 2. Find the quadratic function f such that f4 equals to f negative 2 equals to 0. So what information you have from this line? Okay, what information you have from this line? What's the points you pass through? 4 coordinates. What's the coordinates? X equals to 4, y equals to. What's the y value where x equals to 4? No idea? What's f4 equals to 0 means? What's f4 equals to 0 means? Yes. When you sub 4 in, this equation gives you a value of 0. Okay? So the y value is 0. Okay? So the y value is 0. So from this line, I should know minus 4 and 0 is 1 coordinate. And then not minus 4, it's 4, 0. And minus 2, 0 is another coordinates. And from this, I will know when I sub 0 in, I will have equation out with value 16. So 0, 16 will be the other points. Okay, so those two are x-intercept. And this one is the y-intercept. Okay, you want to find the equation for quadratic. This is quadratic. Okay, what thing you will start with? You have to x-intercept. What formula you use? You have general form, you have turning point form, and you have x-intercept form. X-intercept form, okay. Okay, everyone knows now. Okay, see, multiple choice question is not that hard. Like you have 3 options, you can choose the correct one. Okay. So y will be a, because there's a dilation, always remember this a. Okay, when you start to write any quadratic equation, you always start to write a value because you don't know the dilation. Okay, you don't know the dilation. So which is x minus x1. x1 will be 4 times x minus x2. x2 will be minus 2. So what you have is x minus 4 times x plus 2. And now you will sub 0 and 16 in. So 16 equals to a negative 4 times 2. So a will be negative 8, 16, negative 2. Right? Negative 8 times negative 2 is 16. So a equals to negative 2. So fx will equals to negative 2, x plus 4, and x minus 4 and x plus 2. Okay, sub a back. Sub a back. Yep. If it doesn't ask you to put into general form, you don't need to, but some question will tell you, or put back into y equals to x squared plus by plus c form. So you need to open the bracket and collect the terms. But now it's just not saying, this is a quadratic equation, nothing wrong. Okay, you can leave it like that. So my suggestion is, if not asking you to do so, do not expand it. It's like you can make mistakes in between, who knows. So keep this exact form, this intercept form. Okay. Example 3. F is a linear function such that f negative 5 equals to negative 12 and f7 equals to 6. Okay, so first of all, you know the information, that's a linear function. Okay, that's a linear function. Okay, such that f negative 5 equals to negative 12. What's the coordinates? Yes, negative 5 and negative 12. So I pass through the point negative 5 and negative 12. What's the other coordinates you have? 7 and 6. Okay, so now you have 2 points and you have a linear equation, right? You have 2 points and you have a linear equation. So you want to find the equation for this linear. So you want to start like the steps. Remember the steps I tell you? First of all, think about, do we know the gradient? And second thing, do we know the y-intercept? Okay, that's the step we do linear equation. So do we know the gradient now? We don't know the gradient, so we need to work on gradient. So we need to write the gradient equals to negative 12 minus 6 over negative 5 minus 7. M equals to negative 18 over negative 12. M will be, divided by 2 is 9, divided by 6 is 3, divided by 6 is 2. So 3 over 2. Okay, do we know the y-intercept here? Any information? No. No information, we'll use y minus y1 equals to m times x minus x1. Otherwise, if we know the y-intercept, we'll use mx plus c. Okay, so I can choose any point. Okay, I can choose any point. I will choose the positive one. It looks easier. So y minus 6 equals to 3 over 2 x minus 7. So y will equals to 3 over 2x minus 21 over 2 plus 12 over 2. So y will equals to 3 over 2x minus 9 over 2. Okay, minus 9 over 2. Okay, so I'll write it as fx. Okay, fx equals to 3 over 2x minus 9 over 3. You can change it after you find the equation of y. So that's the equation for this linear. So question A asks you to find f0. So f0, sub-0 in, you have negative 9 over 2. Okay, sub-0 into this equation, you have negative 9 over 2. And you have f1. So what is f1? Sub-1 instead of x, so it's 3 over 2 times 1 minus 9 over 2. And f1 equals to negative 3. Okay, f1 equals to negative 3. 3 minus 9 equals to negative 6. Negative 6 divided by 2 is negative 3. Okay, so f0 equals to negative 9 on 2, and f1 equals to negative 3. Okay. What is part B? Part B is solve the equation fx equals to 0. Okay, now I want to fx equals to 0. So it's same as y equals to 0. Okay, solve fx equals to 0 is same as y equals to 0. Because what fx equals to? Fx equals to this. And you want that equals to 0. Okay, so it's 3 over 2 x equals to 9 over 2. 3x equals to 9, x will equals to 3. Okay, so solve the equation basically means solve fx equals to 0, fx equals to that, you solve for that equals to 0, and you solve out x equals to 3 will be the solution for fx equals to 0. And also that is the x-intercept. Also that is the x-intercept because y equals to 0, x equals to 3. So 3, 0. Okay, next one. The volume of a sphere of radius r is determined by the function with rule Vr equals to 4 over 3 pi r cubed. State the practical domain of the function v and find v10. Okay, so Vr equals to 4 over 3 pi r cubed. Okay, what is the practical domain? So it's the domain can give this function meaning. What is the implied domain? Implied domain is like the number put in will make this equation can find some value. That will be the implied domain. But practical domain will think about reality. For example, length cannot be negative. Area cannot be negative. Probability cannot go outside 0 and 1. So that's the practical domain. But like think about this function. If it's the implied domain, r can be anything, right? R can be anything because no denominator, no square root, no fourth root, no logs. So that should be anything. Implied domain is R. But the practical domain, R will belong to 0 to infinity. Because R is the radius. Your radius cannot be, like you can say include 0 or not including 0, it doesn't matter. Okay, include 0 or doesn't including 0, it's okay. Because your radius can be 0, just no sphere. Okay, there's no objects. So, but it needs to be positive. It can't be negative. If it's negative, then something wrong for radius. So the practical domain will be R belongs to 0 to infinity. So that's called the practical. But R belongs to this R, which is the implied domain. Which is wrong, okay, which is wrong, but I'll just tell you it's the implied domain for this function if there's not telling you R is radius. If not telling you R is the radius, then the implied domain will be real numbers. But because R is the radius, then the implied domain will be 0 to infinity. And I'm looking for V10. So what means by V10? So what asks you to solve? It's actually to solve when radius equals to 10, what is your volume? Okay, when radius equals to 10, what is volume? So V bracket 10 means R equals to 10, what is my volume? So the volume will be 4 over 3 pi 10 cubed. So that is 4,000 over 3 pi. Okay, there's no unit, so we don't need to worry about unit. Okay, so this question is basically talk about what is the practical domain and what is the implied domain. Okay, give you an idea about this. Okay, next page, please. Okay, we have one question, but like this is a pretty good one. It's an exercise from your book. So I'll like go through this with you. So example 5, find the quadratic function f such that fx equals to that is greater than 1 for all the real number x. Okay, for all the real number x. How can we show that all the y values will be greater than a particular value for quadratic? For quadratic, how we can show that all the values greater than a particular level? So what is the smallest point on quadratic equation? Like on a quadratic graph. Where is the smallest point? Turning point is either the maximum or the minimum, right? This is a graph, positive graph. So I'll have this shape. So I'll have a minimum point, right? A minimum point. If I can show this minimum point will be greater than 1, which tell me the information all the rest of the point needs to be greater than 1, correct? So I'm looking for the turning point. Turning point of a quadratic can tell me a lot of information. How we can show quadratic all the points greater than particular level? What you just need to show is the turning point greater than that level. Then all the rest of the points will be greater than that level. So in other words, if it's a sad face graph, like negative graph, if I ask you to show all the points is lower than a particular value, you just need to show the turning point is lower than that value. Then the rest of the points will all below that value. Okay? So now the thing is to find the turning point. So how we can find turning point for this graph? What's the method to find turning point? Turning point for completing square, right? We need to complete square. So let's say we have fx equals to 3x squared minus 5x minus k. Okay, I cannot complete square when there's a coefficient of x squared. So I'll take x squared out. We have x squared minus 5 over 3x. I don't mind this k. I'll keep this k outside. Okay, I just worry about the x squared term and the x term. So put the k outside. I'm not factorize that with 3. So, okay, inside I have x squared minus 5 over 3x. I will add half of that squared. Okay, half of that is 5 over 6 squared minus half of that squared. Okay, minus k. Okay, I don't need the k. Okay, one common mistake will be forget there's a bracket here. Okay, there's still 2 brackets around. Okay, there's still 2 brackets, and I want to know what is here inside. So what this is, x minus 5 over 6 squared. So how I can know that? I know the first x, I need the sign, I need the number. I will combine those 3 things together. So it's x minus 5 over 3 squared. But it's still within this big bracket. And I will minus 25 over 36. Okay. What I will have is 3x minus 5 over 6 squared minus 25 over 12 minus k. Okay, so I forgot to write the question. So it's find the k value of the quadratic function f such that fx is equals to that. Okay, I forgot to say find what. It's find the k value, like this quadratic such that this equation is greater than 1 for all the real x value. Okay, so I have this turning point form. So that's the constant at the back. So my turning point will be 5 over 6, comma, negative 25 over 12 minus k is the y coordinates. Is the y coordinates. So this is my lowest point. Okay, this is my lowest point. So I need this lowest point to be greater than 1. Okay, I need this lowest point to be greater than 1. So I need negative 25 over 12 minus k to be greater than 1. Okay, minus 25 over 12 greater than 1 plus k. Minus 25 over that minus 1 will be this value. Okay, k should be smaller than minus 37 over 12. Okay, minus 25 over 12 minus 12 over 12 is 37 over 12. Okay, so this k should be smaller than negative 27 over 12. So I'll say k belongs to negative infinity, negative 33 over 12. Okay, that should be the k value. Okay, so find the k value. So k should be in between that domain to give you all the values greater than 1. Okay, because the minimum point is greater than 1, then all the rest point needs to be greater than 1. Okay, show that for all k, the minimum value of fx occurs when x equals to 5 over 6. Okay, we have shown that. Okay, we have shown that on the previous question. So by completing square, of part A, we find turning point occurred at 5 over 6 minus that, because it is a positive quadratic equation. So turning point should be the minimum value. Should be the minimum point. So x equals to 6 over 5, y value, so fx value. Okay. Fx value will be minimum. Okay, just explain what's happening. So because it's a quadratic graph and I find out the turning point, and this turning point will be minimum value because this is a positive graph. Therefore, when x equals to 5 over 6, fx will have the minimum value. And the next one is asking, find the k if the minimum value is 0. Okay, if the minimum value is 0, so negative 25 over 12 minus k equals to 0, minus k will equals to 25 over 12, k will be minus 25 over 12. So that is the k value when minimum equals to 0. Okay, when minimum is 0, so we have this k value. Okay, I'll stop here today, and the next week we will spend on chapter 4, gallery of graphs, but I'm not going to spend the whole week on that. I'll spend 2 lessons on that. So I have 4A, 4B, 4C, and complementary thing, and then 4D, 4E. Well, I'll spend a week on this one. I'll spend the rest of the week on this one. If you have, because A, B, C, D is revision from last year, right? A, B, C, D is revision from last year. I will go that pretty quick and emphasize on 4E for you. Okay? Yep. Just wait me a second. Wait me a second.